So now we've done pressure and volume. So now let's try one where we're going to look for temperature. So what is the temperature? So we're doing our given. So what is the temperature? I don't know. Inside a propane tank with a volume of 1,250 milliliters containing 0.8 moles, 0.8 moles of propane. If the inside air pressure is 105 kPa, doesn't tell us R, but we know R is 0.0821. Could check our conversions. That's our unknown, but check our conversions. Milliliters to liters. King Henry died while drinking chocolate milk. We're at milliliters and we're going 1, 2, 3. Here's the decimal. So we're going to go 1, 2, 3. So it's going to be 1.25 liters. Moles is good. KPA. We have to change it. So KPA, changing it to atmospheres. Look in your notes and you will see that 101.3 kPa is equal to 1 atmosphere. kPa divided by kPa cancels to 1. 105 times 1 times 1 times atmospheres is 105 atmospheres divided by 101.3. And plug that in our calculator and we'll get something around 1 point something. Oops. Actually it's 1.036, so we're going to round that to 1.04 atmospheres. Okay? So now we've got our given unknown. Our equation is still PV equals nRT. I still want you to write it because we're going to be adding equations, okay? Later on. What's our pressure? Our pressure is 1.04 atmospheres. Our volume is 1.25 liters equals, our moles is 0.8. Yes, 0.8. R is 0.0821. And now what is our temperature? That's what we're looking for. So we've substituted, now let's solve. So first let's multiply our answers here. So we got 1.04 times 1.25 gives me 1.3 equals 0.8 times 0.0821 gives me 0.06568 times T. We're looking for T, so this number times T. So we're going to divide by this number because we've got to do the opposite. We divide on both sides. That number divided by that number cancels to 1. 1 times T is T, and T equals 1.3 divided by 0.06568 equals 19.79. What's the units for this temperature? It is Kelvin. Okay? Now some questions will ask you to do this and then they will say, well, what degrees Celsius would you have to measure? So we have our temperature equals 19.79 Kelvin. Now we have to convert that to Celsius. So remember our equation, Kelvin equals degrees Celsius plus 273.15. Plug in our K. So 19.79 equals degrees Celsius plus 273.15. We're looking for Celsius, so we've got to get rid of this number. This number is adding, so we're going to subtract from both sides. And so you're going to get that minus that cancels to 0. Okay, so we're left with degrees Celsius equals 19.79 plus 273.15 plus or minus with parentheses should give you negative 253.36 degrees Celsius. So super, super cold. Now, for these questions on your paper, I want you to stop at Kelvin, but know that you could be asked to go to Celsius on your test. Okay? All right. So now next one we're going to take a look at finding the number of moles.